Hello folks, today we're going to be doing 10.5 tangents for geometry. So to save a little bit of time here, I've actually already written out the definition of a tangent. Now we've heard about tangents in trigonometry, and so this should not be a foreign word to us, but we've never seen them in a circle. And so a tangent is a line in the same plane as a circle that intersects the circle at exactly one point, and that point is called the point of tangency. So if we want to draw what this is, say we have circle C here, and we're going to have point A and a line that goes through point A. That line intercepts the circle at exactly one point, and this point A right here would be the point of tangency. So that is what I mean when I'm talking about a point of tangency and a tangent line. So this line, let's call it line B. Line B, can't really see that really well, it is a B, is the tangent line to circle C. There are two theorems that go along with this. So theorem 1 is if you have a circle and a tangent to a circle is perpendicular to the radius if it's drawn to the point of tangency. So what does that mean? Well, if we have, let's say, the same circle here. Actually, let's put the tangent line coming like this. All right. Well, if I draw a line from the radius to the point of tangency, so that means if I draw this line right here, that is going to be perpendicular, 90 degrees. So that is theorem 1. So a tangent is perpendicular to the radius. Let's go, we'll write that out. Tangent, circle, or actually to a circle. Let's be specific. A tangent to a circle is perpendicular to the radius. All right, let's go with theorem 2 then. Theorem 2. I'll draw another circle here. Tangent segments to a circle from a point outside the circle are congruent. So what does this look like? Well, let's say that we have point S outside circle L. And we're going to have two tangent lines here. Let's go TU. Draw one tangent line. Should be straight. It's not. You guys all know my drawings. And we're going to draw another tangent line that goes through point S. So again, if we have two lines that touch the same point outside the circle that are both tangent to the circle, that means that these two chords or these two segments are congruent. That would mean TS is congruent to US. All right, so let's do two examples with this. So if we have here, let's come right here. If we have here this circle in our theorem 1, AC, and let's say that we're going to connect it to point D out here. There we go. All right, and we're given that this is, let's see, this is 14. So this is 14 right here. And our hypotenuse is 50, and this is going to be 48. What I want to know is this segment tangent to the circle? So is this segment a tangent line? Is this segment a tangent line? Well, you're going to be doing Pythagorean theorem. If Pythagorean theorem works, then this segment is tangent. So that means 14 squared plus 48 squared should equal 50 squared. Check that, and let's actually pull out a calculator and check it. So we have, all right, let's go 14 squared plus 48 squared. Well, equals 2,500. All right, what about 50 squared? 2,500. So this checks out. So yes, this is a tangent line. All right, let's look over here. Let's say that we have, this is 7x minus 3, and this is 5x plus 1. Well, again, we're going to be finding x, and so we're going to set 7x minus 3 equal to 5x plus 1. Solving, let's see, 2x equals 4. We have x equals 2. And so that kind of sums up all the things in 10.5. It's a very short lesson right there. Again, using Pythagorean theorem for this theorem 1 right here, knowing that all segments that attach to the same point are congruent. Again, you could have this coming out here, and you could really have a circle going on right here. And all of these would be congruent. Note that these two are congruent to each other, those two are congruent to each other, and those two are congruent to each other. So there we go for 10.5. You need to take a screenshot and have a great time.